Now the QR code for section 2. Okay, Assalamualaikum warahmatullahi wabarakatuh and very good afternoon to everyone. Can you hear my voice very clear?
Yes,
Good
doctor.
afternoon.
Okay, so we are going to have a very short tutorial class. So I'm going to discuss the answer for the quiz one. Okay, so for your information, this quiz one will contribute to the coursework mark of your coursework mark for this course. Okay, so without further ado, okay, let's discuss question number one. Okay, this is very um very simple questions. Let's okay. Okay, questions number one. During the isothermal heat addition process of a Carnot cycle, 900 kilojoule of heat is added to the working fluid from a source of 400. Okay, so it's easy for you to draw the schematic diagram so that you can imagine the transferring of heat from the source to the sink or vice versa. Okay, so question number one. Okay. Okay, let's okay. So this is source. Okay. Working fluid. Okay. Okay. Right. During the isothermal means that both of these source and the sink that consists of the working fluid consists of same temperature, which is 400 degrees Celsius or 673 Kelvin. Okay. Can you see my hand written here?
Yes, doctor.
All
Yes,
right.
doctor.
Okay. So please follow me. If you are unable to hear or to see anything on screen, please let me know. Okay. All right. So it states here isothermals heat addition process of a Carnot cycle. So this is a Carnot cycle. Okay. It consists of working fluid. Okay, from a source at 400. So here also consists of the same temperature of 400 degrees Celsius, 673 Kelvin. Okay, then heat added means heat is being transferred from source to the working fluid as 900 kilojoule. Okay, so this is the way. Okay, so for Q source, it is a negative because heat is being removed from source to working fluid, and at the working fluid, it is a positive sign of heat because it is receiving heat. Okay, so determine the entropy change in kilojoule over Kelvin of the working fluids here. So A at the working fluid as QF over TF working fluid. So since fluid is receiving heat, okay, then positive 900 kilojoule over 673 Kelvin. Okay, so you may get the answer positive about 1.337. Okay. The unit must be in kilojoule over kilogram because it states here kilojoule over kilogram. That's why we convert the degree Celsius to Kelvin. Okay. All right. So I move to questions B, 1B. Okay. This is the contrast from a fluid. Since fluid is receiving heat, then source is removing heat. Then the negative this is not F but S. Okay, S, T, S. Okay, so negative 900 kilojoule over 673 Kelvin. So you may get the answer, the same value but different sign. Okay, also same unit. All right, is that clear? A and B?
Yes.
Yes. Okay. Good. Then total entropy change here is a Sgen, and we know that Sgen is equal to S total, and we know that the S total is the summation of the S of the system plus S of the surrounding. Okay, so in this case, our Q system, our S system is a working fluid, and the surrounding is come from a source. Okay, it came from source. Then for C, okay, it is good for you to practice yourself to make a very perfect solution. So by writing a complete formula, okay. So entropy generation is equal to S total is equal to S of the fluid, okay, which is the system plus S of source, and then you may get 0. Okay, 0 here because same magnitude but different sign. Okay, you may get 0 kilojoule over Kelvin. So from here, we can conclude that there is no there is no entropy generation produced from this process. Okay, because it is isothermal. Okay, isothermal heat addition. All right, so I think I have done answering question number 1. Do you have any questions so far? Do you have any questions so far?
No.
Is it clear?
Yes, doctor, clear.
Okay.
Yes.
All right. Okay, then we move to question number 2. Okay, we have about 15 to 20 minutes left. Okay. So question number 2, change the okay. like- Okay. During the isothermal heat rejection process of a Carnot cycle, the working fluid experiences an entropy change of negative 1.3 kilojoule over Kelvin. This is the contradict from question 1. Okay, then if the temperature of the heat sink is 35 degrees Celsius, heat sink, removing or rejection of process. So come out with the schematic diagram. So you may get the very clear picture of this process happening. Okay, isothermal heat rejection of a Carnot cycle. So Carnot cycle, here I use the closed piston cylinder that consists of implementing or conducting a Carnot cycle inside. Then heat rejection process, isothermal, T here, T system is equal to the T sink. Okay, so let's say this is the sink or surrounding. Okay, working fluid inside in the system in the Carnot cycle. The working fluid experience an entropy change between the system with the sink is about negative 1.3 kilojoule Kelvin. Okay, if the temperature of sink is 35 degrees Celsius, here is also 35 degrees Celsius. Okay, examine the amount of heat transfer. Amount. Okay, please ignore the sign because it asks you about only the magnitude or amount. Okay, so how do you want to make a perfect solution? Okay, from here we come up with the okay, let's say system here that consists of fluid F over T fluid. Okay. So whether you can choose one. Okay. You can choose either system or sink. It depends on the information given. So from here, it says Carnot cycles. So you may focus on the Carnot cycle or working fluid. Okay, then the entropy given as negative 1.3. Okay, so here the system negative. Heat rejection process. So from here, heat rejected. Once the heat is rejected, the negative Q is being displayed. Okay, is being displayed for the working fluid here. Okay, so QF, rearrange this equation as F times temperature of the fluid. Okay, then we know here, once it is rejection process, it came from working fluid or system. So um you may use this value, okay? Negative 1.3 given kilojoule over Kelvin, then times to the temperature of the system. Okay, since this is isothermal process, means the temperature at the sink also same goes to temperature at the system. Okay, then you convert to Kelvin, you may get 308 Kelvin. So the answer is 400.4, okay, kilojoule. Okay, so here Q fluid is 400.4 kilojoule negative. But you may display the answer as 400.4 kilojoule only. Okay, if you also write negative, so it doesn't have a problem, is also acceptable. Okay, then from here, we can estimate the value of Q at the sink. Okay, Q sink is positive 400.4 kilojoule here because it is receiving heat from working fluid. Only the direction is different and it is represented by different sign. Is that clear? This is the answer for A. Is that clear?
Yes, doctor.
Okay, then we move to B. Okay, we move to B. Identify the entropy change of the sink. Okay, so since we know the sink, the heat transfer to the sink is 400.4 kilojoule. So sink here is Q sink over T sink. Okay, Q sink is positive 400.4 kilojoule over T sink is 308 Kelvin, and you may get the answer about 1.3 kilojoule over Kelvin. All right. So this is the answer for B. Okay. Then for C, calculate the entropy change in kilojoule Kelvin for this process. So total is equal to Sgen is equal to sink S sink plus S system fluid. There you may get 0. Sink is 1.3, fluid is negative 1.3. So once you sum up, and then you will get 0. So this is the answer complete. Okay. Alright. Do you understand? Or do you want me to repeat somewhere? Which part that you are not really understand? Do you want me to repeat at certain point?
Continue, Doktor.
Continue faham Very, very clear Very clear
Yes, doctor.
Okay, so we go to question 3. This is a very the hardest questions compared to these two above. Okay, question 3. Saya kena bawa sikit bawah. Alright. Kita guna pen warna merah lah. Okay, pen warna. Right. Okay, warna purple color. Okay, a well-insulated rigid tank contains of 3 kilogram of saturated liquid vapor mixture of water at 200 kilopascal. So here, a well-insulated rigid tank. Okay, so for question number 3, you need to focus at two different conditions. Initial condition and the final condition. Okay, so both are contained in the well-insulated rigid tank. Okay, a well-insulated rigid tank means that it is a closed system. Then the volume is very specific and it doesn't change. The volume is specific and it doesn't change. Okay, so it's easier for me to draw the schematic diagram that state the initial and final condition. Okay, initial and final condition. Okay, we know that from here a well-insulated rigid tank. Okay, means V1 here is equal to V2. It doesn't change. Okay, contain of 3 kilogram of saturated liquid vapor mixture of water. So you focus to table A4, 5, 6 and 7. Okay, it contains of 3 kilogram. 3 kilogram. Okay, then here it states at an initial point, it is stand at saturated liquid vapor mixture of water, means it involved with quality because it is a mixture. And the pressure is P1 is 200 kilopascal. Okay, initially 3/4 of the mass is in the liquid. We know X quality present. Okay, X is represents the how much the vapor in the mixture of liquid and vapor. So if liquid consists of 3/4, means 3/4 means the vapor is 1/3, 1/4, 1/4. So 0.25. Understand? Do you understand? Do you understand
Yes,
this?
doctor.
Okay. So 0.5. Okay, 0.5, 1/4 is vapor. Then here, liquid is 3/4. Okay. Jadi quality ni how much the how much the vapor. Okay. So here is that 1/4 is equal to 0.25. Okay, then you go to table A A5 pressure, saturated pressure. You go to table A5. I think A5. Okay, saya bagi you cara je Okay, I give you the way how to get the V1 since you play with quality here. So, you need to find V1 from this equation. VF plus X1 VFG. Okay. So, from table A5. Okay, how do you want to refer? You go to table A5 at 200 kilopascal. Okay, then you get the first column, which is VF. And then you get VFG, which is VG minus VF. And then you will get V1 is equal to 0.22224. Okay, meter cube over kilogram. Do you get this? Do you get this?
Yes, doctor.
Okay. 0.22224 meter cube kilogram. Okay. From here, we know that V2 is rigid. V2 is equal to V1. So, V2 also 22224 meter cube kilogram. Okay, meter cube kilogram. Okay, an electric resistant heater placed in the tank is now turned on and keep on until all the liquid in the tank is vaporized. Means you refer to saturated vapor. Now X is 1. Okay, X2 is 1. Okay, so now you have V2. Okay, you have V2 0.22224 meter cube per kilogram, and X is about 1.0, which is saturated vapor. Okay, then you can refer to V. Okay, you cari V. Okay, you cari V, which is V dengan S and then you come out with interpolation. Right. So let's say V2 is 0.22224 and then atas dia berapa? Sekejap. 0.800. Okay, 100. You go to table A5, 0.22690, 0.22690, 0. Ish. 0.2690. Can the others, the bottom part is 0.21489. 0.21489. 0.21489. 489. Okay. So from here, okay, in between, pressure 850 to 900. Okay. So you may get what is S2. Yang ni you isi sendiri and then you will get S2. Okay. Alright. One more thing. Okay, one more thing here. V1. Once you get V1 here, okay. Now we solve for V1. Okay. V1 and also V2. Okay, for S1. Okay, for S1, you can also use this X to find what is S1 SF plus X1 SFG. Okay. Then the answer 2.9294 kilojoule kilogram Kelvin. Okay. Then from here you do the interpolation and then you will get S2. Okay, I will give you the answer 6.6338 kilojoule kilogram Kelvin. Okay, then the answer, determine the entropy change of the steam during this process. Okay, saya letak di bawah sini. Okay, so the entropy change is, this is a total entropy M. We know that this is a rigid, therefore there is no mass in, mass out. The mass is being keep consistent. S2 minus S1. Then you may get, you replace M is equal to 3 kilogram. And then you may get the answer is about 11.1 kilojoule over kilogram. Okay, so I think a bit harder point is at this part. Okay, and also the some of the critical point this part and also at this part interpolation. Okay, so for this interpolation, I need your cooperation to refer back to table A5. Okay, to table A5 to get the exact value. Okay, because some of you get different values and mine is different because we are referring different sources. Okay, all right, so basically this is the idea. Okay, so I think that is the content for this tutorial class. Okay, so I open to the questions. Do you have any questions to ask me? Okay, so the black one is question number 1, solution for question number 1. The blue solution is solution for question 2. And the purple color is the solution for question 3. Okay, I think question 1 and 2 is simpler as compared to question 3. However, for question 3, I think you need to refer back. Okay, refer back to table A5 to get the point, to get the exact point. Okay, all right, any questions? Any questions? Not from me, Harshini. Okay. What about the others? Okay, no, doctor. So once you said no, very clear. Okay, I think that you get some time to digest and also to redo. Okay, to redo. Okay, however, okay, I think that is the I will upload the solution to the e-learning insyaallah by this by today the earliest. Okay. Then, in order for you to strengthen your knowledge on the entropy principle and also the entropy principle and also the entropy of a pure substance, okay, I will give you quizzes. This is a very this is a individual quiz. Okay, give me some time to open up the quiz. Okay, so can you see this? Can you see this?
Can Doctor?
All
Can,
right.
Doctor,
Okay.
can.
All right. So I don't want to play with you. Okay, because it's up to you. When do you want to answer this quiz? Okay, this is not live, but this is just for your strengthen your knowledge. Okay, but I need I'm encourage you to answer these questions to strengthen your understanding, the level of understanding. Okay, so the link is joinmyquiz.com. So the enter join code is 456048. Okay, once you get this code, there are about 8 questions, very simple questions. Okay, you may answer whenever you're free. Okay, so I think that's all for my class. Okay, do you have any questions? Okay, to those who has not scanned the QR code, you may still remain in this group, and the others, thank you very much for your attendance, for your cooperation, and I will see you again next week, inshallah, next week, Thursday. Okay, thank you very much. Assalamualaikum and very good day.
Thank you so much, Doctor.
Welcome.
Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Welcome. Boleh buka ke saya punya quiz?
Boleh, Doctor, boleh.
Is there anyone who still has not scanned the QR code? Me. Okay, Nur Ain. Nur Ain. Okay, let me please give me a few second to display back. From which section you are from, Ain?
Section 1, Doctor.
Section 1. Okay, section 1. Bunyi. Okay, Ain nampak tak?
Yeah, can.
Okay, done?
Yeah, okay. Thank you, Doctor.
Okay, welcome Ain. Okay, then the others? Okay, thank you very much.